morning, student. This is Sachin Fiske from SND College of Engineering and Research Center, Department of Electrical Engineering. In the previous chapter, we discussed about the introduction related to PLC system. Today, we are discussing about the various components which are applicable along with the PLC systems. Now see here, some major parts just like a variable frequency drive. This variable, what is meant by variable frequency drive and how it works will be discussed in this lecture. So here, what is variable frequency drive? First question arises and it is called as VFD. It is a very short drive, or basically it is a motor controller generally used in the field of electrical engineering. Here we see a variable frequency drive is basically a type of a motor controller that drives an electric motor by varying the frequency and voltage supplied to the electric motor. Generally, these two components or two parameters of the electrical engineering, just like frequency and voltage, can be controlled. Means the ratio of frequency and voltage can be maintained very easily by using this variable frequency drive. Hence, the other name for this variable frequency drive are variable speed drive, or it is also called as adjustable speed drive or adjustable frequency drive. Sometimes it may be called as AC drive or micro drive or an inverter drive also. Means the frequency or hertz is directly related to the motor speed, that is RPM. In other words, we can say that the faster the frequency, the faster will be the RPM goes. And if an application does not require an electric motor to run at its full speed, the VFD can be used to ramp down the frequency and voltage to meet the requirement of the electrical motor load. As the application motor speed require changes, the VFD can simply turn up or turn down the motor speed to meet the speed requirement. This is a simplified block generally used for variable frequency drive. Means variable frequency drive just look like this one. So here some different type of switches are given. By using these switches, we can run the motor, or we can stop the motor, or we can change the speed of the motor by controlling V by F ratio. What is V? Here the V means voltage and F means frequency. Generally, voltage can be changed by using thermostat or rheostat, but frequency can't be changed, or there is no any other devices to control or change the frequency. And hence, this device can automatically maintain the V by F ratio, that is constant. And generally, this device can be used along with the PLC system to maintain V by F ratio constant. Now, how it works? So let us see. The first stage of the variable frequency AC drive or VFD is the converter. The converter is comprised of the 6 diodes. See this in this diagram. There are 3 phases, that is phase A, phase B, and phase C. Generally, we call RYB, but in this diagram, for the simplicity, we consider this as a B, C, and 6 phases along with the 3 phases along with the 6 diodes are given. So this converter is basically comprises of 6 diodes, which are very similar to the check valve generally used in plumbing system. They allows the current to flow only in one direction. Means the direction shown by the arrow in the direction is indicated by the diode symbol. For example, whenever A phase voltage, see in this diagram, when A phase voltage, for example, voltage is similar to the pressure in the plumbing system, is more positive than phase B and phase C voltage, then that diode will open and allows the current to flow in a particular direction. Similarly, for phase B and C, when phase B becomes more positive than phase A, then the B phase diode will open and the A phase diode will close. The same is true for the 3 diodes on the negative side of the bus. Thus, we get the 6 current pulse as each diode opens and closes, and this is called a 6-pulse VFD system. Similarly, we can apply this system for the 12-pulse diode or 12-pulse VFD system also, which is the standard configuration for the current variable frequency drive. Let us assume this drive is operating for voltage 440 power system, and this 440 volt rating is the RMS or root mean squared. The peak on 440 volt system are 679 volt. As you can see, the VFD DC bus has a DC voltage with an AC repulse, because here initially we are applying a three-phase system and the voltage runs between approximately 580 volt to 680 volt. Now we can get a read of the AC repulse on the DC bus by adding a capacitor, and a capacitor operates in a similar fashion to a reservoir or accumulator in a plumbing system. This capacitor absorbs the AC repulse and delivers a smooth DC voltage. This is simple construction and working of a simple VFD system. So this is the graph which is shown, means the ratio or the voltage level which can vary in between 440 volts to 680. Generally we show one of the voltage range, means we can change the level of the voltage by adjusting the frequency to maintain our V by F ratio constant. As per this, we are taking a voltage range that is 540 volts to 680 volts, and hence this graph will be shown according to the same. Okay, so this is all about the working principle of the variable frequency drive used in electrical system. Thank you. वो अपने YouTube भी एक चालू था, फिर से करना पड़ेगा।